I have this. So you guys, let's talk philosophy. I think when I take a peek at this integral, guys, I just can't snap my fingers and say, ah, jeepers, I recognize off the top of my head an antiderivative for what the heck we see in the integrand's position. That being the case, you guys, I got to use some other sophisticated technique like a U-sub. Oh shoot, I just tried. I exhausted all possibilities. I don't see one. Or maybe some other sophisticated technique like integration of parts. I don't want to do that. That's a lot of work.
What's in the parentheses right here?
A t plus 1.
T plus 1.
Can we change it to x?
Yeah, yes, we can change to x. But you guys, since what I see in the integrand's position is actually a rational expression, namely a ratio of two polynomials, I think a prime candidate is committing to partial fraction decomposition. Let me not do the work yet. I just want you to look at this alternative integrand, which is not going to, I'm not going to do anything illegal, no tricks. I just want a yes or no answer. If I can split this one fraction up into some of these three, something over x, maybe plus something over x twice, plus maybe something over x thrice, plus maybe something else over x plus 1, I want a yes or no answer. Would you be able to snap your fingers and anti-differentiate turn-by-turn piece of cake?
Yes.
I think so. And that's the whole logic and idea and philosophy behind this idea of partial fraction decomposition. And you got to confess, for given constants a through d, if I were to go backwards and add these three fractions, I'll get a fraction with this common denominator. So if you don't mind, I'm going to pull out my piece of scratch paper, and I'll commit to partial fraction decomposition. I'll consider that fraction 2 over x cubed times x plus 1, and rewrite it as I suggested. We could rewrite it and come up with an integrand that's easy to anti-differentiate. You guys tell me if I'm writing or speaking too fast. Confess. It's my mathematical responsibility to find the values for a through d no matter what x is. So if you don't mind, I'm just going to make my life easy and clean up the equation. I'll get rid of fractions. I'll multiply both sides by x cubed times x plus 1. Here's what I got. And you guys watch how I'm successful at actually, whoops, I'm not successful, sorry. But now watch how I'm successful in removing all the fractions. It's just making my life a little easier. And I have to confess, this could be problemsome in terms of workload, although it's only arithmetic. Because now if I were to blow everything up on both sides, equate coefficients, I'll end up with 4 equations and 4 unknowns. It works. It works every time. You've got multiple techniques. I'm tired. I don't want to do it. So if you guys don't mind instead, I'm simply going to allow x to be 0. I don't know. I'll panic. Any one of these linear factors. For example, if I let x equal 0, I think something nice happens. Every single term on the right-hand side cancels out, goes away, except for that one. Yes?
So you multiplied all the numerators by all the denominators multiplied together. Well, what happened to the x cubed?
Can I say it a little differently than the way you did? I would say this more accurately. I'd say I multiply both sides by the LCM of all 5 of these denominators. And I think the smallest expression up here, into which these 1, 2, 3, 4, 5 denominators divide evenly, is just this. So Reza, I'm being this lazy. I'm saying let's multiply both sides by that darn red beast. And by the way, being a little careful with our algebra. On the right-hand side, let's be careful and distribute and cancel legally. And that's how those things kind of disappeared. But at least the upside to all this garbage, no fractions. And I think it's true. That when I plug 0 for x, everything drops out except for this term on the right-hand side. That just gives me a c. On the left-hand side, I got a 2. Check this out. I found the value of that constant C. And again, like lazy fashion, just set up to a lot of arithmetic. You know me, I make mistakes all the time with my arithmetic. Now allow me to let x be the zero of another linear factor I see somewhere, anywhere, panicking up.
Negative 1.
Negative 1. But when I plug it in, everything drops out on the right-hand side except for that term. And it tells me that d is equal to, is that a negative 2? And I know I'm running out of gas. I'm running out of ideas, or should I say, running out of linear factors for which I can pick zeros. So I guess the next best thing is just, I don't know, how about equating constants or coefficients of x, or x squared, or x cubed, whatever I can. How about x cubed? If I were to equate coefficients of x cubed, on the left-hand side, what's the coefficient?
0.
On the right-hand side, what is the coefficient of x cubed? I can't hear you.
A plus D.
That's better, a plus d. But you know what? I've already got a value for d, it's negative 2. When I plug it in, I think that tells me that a is equal to positive 2. Do you guys agree? Next, actually, you know what? Let's be more selective this time. What am I missing? What do we need to find? B. So to find b, let's go ahead and equate constants. Are you ready?
So how did you get a is equal to positive 2?
Because I plugged negative 2 in for d,
Okay,
added to both sides.
okay.
So you guys ready to equate constants?
No,
What do you know? Why not?
because B doesn't have a constant.
Thank you. I don't think that'd be an appropriate choice, would it? Because I think when it comes to this term right here that involves the b unknown value, that when I distribute it in, there isn't a constant term. So guide me. What coefficient should I equate to find b?
X squared.
X's or x squares, I don't care which. How about x's? And if I were to equate coefficients of x, on the left-hand side, got it. Now I'll slow down. On the right-hand side, I guess there's no coefficients of x here when I expand, but here the coefficient of x and b when I expand. I also get a c next door. Oh, you know what? That's it. But I got a value for c, it's positive 2. What does it say about b?
Negative
I agree. But can you guys appreciate how lazy I am? I didn't do a lot of work. I didn't really blow up the system 4 equations of 4 elements.
Did you say if x squared would equal or not?
I said I could have equated coefficients of x squared instead.
Okay.
After all, when you look at this term right here involving the unknown b value, notice when I distribute I get an x squared term. I'm just saying that would have worked just as
Oh,
easy.
okay.
Oh, shoot, I guess I'm done. Well, plugging everything in, if I can cheat with my race since I'm running out of room. A holds the value of, my glasses aren't on, help me with this.
A was value 2.
2? What's B?
Negative 2.
What's C?
2.
What's D?
Negative.
Let's see if you and I can't just write our answer.
2 natural log of x.
Minus 2 over x. Minus 2 over x squared.
Minus what?
Or minus 6 over x squared.
6 to natural log.
Really?
Isn't it?
That's-
Oh, no, minus 8 over x squared.
I just can't.
Or 8 over,
It's 4, right?
no, sorry, 4 over x, 4 over x
I'll close
squared.
my pen.
It actually is 4. It actually is 4.
It's what?
1 over x squared?
Wait, say it again.
1 over x squared?
Thank you. Are we there?
Yes.
Okay. Next.
Minus 2 natural log of 1 plus x.
In absolute values.
Yeah.
Is that as pretty as it gets? Is that as pretty as it gets?
No.
What do you know? What
You can combine the logs and use them.
Yeah.
Oh, how nice.
Don't you have to figure out the value signs?
Not when I square things.
Oh, you square them there.
That's it.
Because you move the slope.
Yeah, I agree.
So if we didn't clean up the natural log part of it, how much would that be subtracted?
Minus 10 points.
You don't really want me to think about that, do you? You never do that.
The book does it on every single answer.
Does what?
They don't clean it up on every answer.
Don't tell me that. Don't look in the back of the book anymore. Okay?
Okay.
You serious? He really doesn't clean anything up?
Yeah, I mean, I was cleaning it up,
Oh
but
my gosh.
let's look
I
at
don't
that.
even like the way I wrote these two terms. I would have pulled out a 1 over x squared, to be honest.
Is that minus 1?
Don't be like that.
Is that, no, over?
guys, I have to admit with this example right here, if you can read my sloppy writing, you guys, I'm sorry. It's because I rushed over to class from across campus. I'm being way too sloppy. Jeepers. Is that better? Now I confess, when I take a peek at this integral, I can't just kick my feet up and say, I know an antiderivative for what's the integrand's position. I can't just like that. I don't know one. I also can't confess I can't make a u sub. I mean, what's u going to be? I've only got a few choices. U could be x. That just changes the name of the variable. U could be equal to secant of x, but its derivative is secant tangent. I don't see a tangent. I could let u equal secant squared, but its derivative also will involve a tangent along the way. I don't see one. I can let u be equal to secant cubed, but here too, no tangents for me to deal with. I think even a u sub, after exhausting all those possibilities, isn't going to do me any good. I do, however, think that if I just shave off a factor of secant squared of x, that happens to be the derivative of something else. And often, when I can shave off a factor and it's derivative of something else, it just screams out at me that integration by parts might be the correct approach. Just give it a shot. Allowing dv to be the secant squared of x because I can anti-differentiate it. I guess that means that u is going to be everything else left over as factors from the integrand's position. David?
Well, what if you have two factors and they're both easy to differentiate and derive?
Then I think in a case like that, you might have to finagle that and kind of play with it and see which one might be the better option. See which one, David, would give you another integral with a v du that looks like it'd be easier to integrate or cycles back to something that looks like what you started with.
Okay.
And I think u, therefore, is going to have to be everything else. And I'll pay the consequence of my actions. Let's see if it helps. I think that tells me that this integral right here is equal to the product of my u and v minus the integral of my v du. And you guys keep in mind, here's what the integration by parts formula hopefully gives us. It allows us to trade an integral, which is relatively nasty to deal with, in for an expression involving another integral that's just a heck of a lot easier to integrate. But now that I take a break and look at what I have over here, if I'm being honest, I don't think that's easy to integrate. I think it's just as nasty as what I started with. And whenever something you get over here is just as nasty as what you started with, it kind of suggests that maybe we can do it again or cycle back. I don't know. Do you see a secant cubed in there somewhere?
Well, you could change tangent.
I think in evoking that second Pythagorean identity, another name for tangent squared of x will involve secant squared of x, which means multiplying by secant of x again, oh look at that, is secant cubed of x. Do you see my point? So maybe not applying integration by parts formula again, but merely playing with my trig identity, since you and I are proving ourselves to be experts in trigonometry, right? Yeah, we really have. I think I get this. Or can I restate that? I think I get this. You guys, I'm being honest, seriously. Isn't that slick?
Yep.
Because now I can take this equation, add the integral of secant of cubed x to both sides. I get 2 times the integral of secant cubed of x with respect to x equals this product. Plus, you guys, can we just deal with it?
Natural log of absolute values.
Which means, of course, when I divide both sides by 2, look at that, I've answered the question. Secant cubed of x with respect to x is nothing more than 1/2. Secant of x tangent of x. Plus 1/2 natural log of the absolute value of this sum. Plus another constant. Maybe I can call it C1. I'll just call it C. 1/2 times the constant is just a constant.
When you're going through the process and you have multiple intervals to evaluate,
Yes.
if you evaluate one and kind of go next step, go and just to make your solid life easier and evaluate the other, would it be proper to put plus C after you evaluate one, or do you have to evaluate all of them and then put plus C?
No, I think once you have one of the C's in there, you're done. Think about it, David. What if I ended up getting a plus C over here as well? Then I subtract C from both sides and get C minus C equals C again.
Okay, so.
That's why I just don't think it's relevant.
So as long as you evaluate one, the C is, follows you throughout the process.
Now, I have to confess, if this were an application, I might be given some initial value conditions in which I might want to find the cost of C. And if that were the case, I'd probably be a lot more careful. In applications like that, particularly Math 33, I probably would have said, oh, it changed, I'll call it C1. Where, and I'll remind myself, the C1 is simply equal to 1/2 C, so that if I'm trying to find my cost and give it some initial value condition, I can keep track of where I'm at, where I back substitute.
Okay.
I'll get better practice with constants if you give me a couple semesters.
Oh.
It's just not proven here. Brad, did you ask this question?
Yep.
Satisfied?
Oh, yeah. I think I just put a positive where the negative was, and so I was looking at that.
And you know,
I
if
was
that
like,
ever happens,
Yeah.
that just simply means that you made a mistake.
Yeah,
Or if you haven't made a mistake, it means integration by parts is not the way to go.
okay.
It doesn't yield any conclusions.